All right, in this video, we're going to look at some properties of logarithms. Okay, and using those to do some manipulations and things. Um, so again, logarithms are really exponents. So these properties are really properties of exponents. So if you think about them that way, it makes sense why they work the way they do. So log of a base number of that base number. So anytime you have the base of your log and the value inside are the same number, this is equal to 1, because the power of a number to give it itself is the first power. If you have log of some base number of 1, that's 0. Again, any number to the 0 power is 1, other than 0. Log of a base number, that base number to an exponent of its own, is equal to that exponent. Oops, this doesn't look like an n. Is that exponent. So example of this would be something like the natural log of e is 1, right? Remember, natural log is log base e. So this is saying log base e of e is 1. Or log 2 of 2 is 1. So the power of 2 that gives you 2 as an answer, it's 1. The second property, log 3 of 1 is 0. The natural log of 1 is 0. Any log of 1 will equal 0. And then whenever the powers match up, so you have the natural log of e to the 6, that's going to be 6. Again, the bases match. What power of e gives you e to the 6th power? Well, the 6th power does. Or the natural log of 2 to the 8th, that's 3, because 2 to the 8th is 2 to the 3rd, or sorry, 8 is 2 to the 3rd. So that's going to give us 3. The exponent is 3. So those are some basic properties. There's some inverse properties. A base to the log base of that number equals whatever the value is of the log. In fact, that's what the definition of a log is. When you say 3 log 3 of 7, log 3 of 7, by definition, is the power of 3 that will give you an answer of 7. So if you take 3 to that power, your answer has to be 7. So as long as those bases match, the value inside the log is what your answer is going to be. Likewise, like the property we just talked about, those are going to cancel out. Log 3 of 3 to the 5th is 5. Again, those properties match, those bases match. This inverse property gives you that. So that's that third property we looked at first. So those are inverse properties. Then there's properties for combining or expanding logarithms. So again, these are really rules of exponents. So log b of m times n equals log b of m plus log b of n. So again, think of this as exponents. This log b of m times n is saying, what's the power of this base that would give you whatever this product answer would be? This m times n. And that power is equal to the power that would give you this number plus the power that would give you that number. So let's say we had log 2 of 4 times 8. Okay? So according to this property, this would be equal to log 2 of 4 plus log 2 of 8. Well, log 2 of 4 is what power of 2 gives you an answer of 4. And that would be the second power. Log 2 of 8 is what power of 2 would give you an answer of 8. and that would be the third power. That's 5. Well, 4 times 8 is 32. What power of 2 would give you 32? 2 times 2 is 4, times 4 is 8, times 4, or sorry, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, that's 5. Same answer. Now, this is kind of a simple example, but we're going to use this to break up things that we couldn't simplify. So something like, what's log 2 of, let's say, 40? Well, you can say that's log 2 of 8 plus log 2 of 5, right? Because 40 is 8 times 5. The power of 2 that would give you 8 would be 3. And the power of 2 that would give you 5 is log 2 of 5. It doesn't break down. So we can split numbers up using this property to reduce them or simplify them. That's one of these properties. Second property, log b of m divided by n is log b of m, oops, that's not that, try it again, minus log b of n. So this is like the previous problem. Previous problem, you're multiplying, so you add the logs. This one, you're dividing, so you subtract the logs. In exponent rules, if you're multiplying, you add the powers. If you're dividing, you subtract the powers. That's what's going on here. So we could have something like log b of, or let's make that an 8. Log 8 of 64 over 7. And you could go, well, that's equal to log 8 of 64 minus log 8 of 7. What power of 8 gives you 64? 2. And what power of 8 gives you 7? Well, it doesn't really give you that, so log 8 of 7. That's the number. When I say it doesn't really work out, this is an irrational number. So you're not able to write it out neatly other than writing it this way. So this would be your answer. If I said expand that out, simplify it, this would be the simplified answer. And then a third property is, for expanding, is if you have an exponent inside, or sorry, I did that wrong. We already did that property. If I had something inside with an exponent, I can move that exponent outside as a multiplier. I can move that exponent outside as a multiplier. Now, I've been pretty much talking about all these properties going in this direction. So I can bring the exponent out front. I can change a division into a subtraction. I can change a multiplication into an addition. But in reality, these also go the other way as well. And sometimes you'll want to take things that are split apart and put them together. We call that condensing the expression, or writing it in terms of a single logarithmic expression. So, I want to go back the other way. So this third property here, this would be like x squared. You could change that into 2 log 3 of x. You could take that exponent from inside and just move it out front as a multiplier. And again, since logs are exponents, the rule is when you have a power to a power, you multiply those exponents. So you're multiplying the exponent of 2 times the exponent that's the logarithm in that case. So again, all these are properties of exponents just in a log format. On your homework, what you're going to be doing is they're going to ask you to do some expanding. Expand out expressions. So let's say we have log 3 of 9 x squared over y cubed. And I want to expand that out as much as I can and simplify anything I can simplify. So I think about those 3 properties I had, m times n, I could split those up and add. M divided by n, I could split those up and subtract. And if I have a power inside, I can move that power out front as a multiplier. So those are the three, when you're doing these expansion, and those are the three big ones that you want to keep in mind. So the first thing that kind of jumps out at me here is I'm dividing. So I'm going to use that second rule and split that up into two logarithms, one of the numerator minus the log of the denominator. Okay. Then the next thing I notice is I am multiplying between the 9 and the x squared. So I can split that up using the first property on here. So log 3 of 9 plus log 3 of x squared, and then I still have minus log 3 of y to the third. And then the third property says if you have a power inside, you can move that out front as a multiplier. So notice x squared and y cubed, I can move those out. Log 3 of 9 plus 2 log 3 of x minus 3 log 3 of y. There's one more thing I can do, and that is log 3 of 9, what power of 3 gives you 9? I know that number. That number is the number 2. So I can change that to a 2. And now I have things expanded out as far as I can and simplified if possible. So that's expanding. It's not always going to be this complicated. Sometimes it'll be more complicated. You just kind of have to look at the problem and try to use those properties. The other side of that is to condense the expression, or sometimes we'll say write it as a single logarithmic expression. And it's basically going the other way. So I'm going to do this problem. I'm going to show you two different ways to do it. Well, I'm going to show you one, and then I'll kind of talk about another one. So let's say I have 2 ln x minus 3 ln y minus ln z, okay? And I want to squash all those into one logarithm. So I'm basically going to do what I just did backwards. So the very last thing I did before I calculated the log 3 of 9 was to move those exponents out front. So that was the last big log property thing I did. So what I'm going to do is I'm going to do that step first here, and I'm going to move these exponents up here. All right? So this is going to be the natural log of x squared minus the natural log of y cubed minus the natural log of z. Now I can do this problem this way. The next thing I'm going to do is I'm going to say I'm subtracting, and so I'm going to divide. So I would put the first two together and divide the inside parts. And then once I got that answer, I would put that answer together with this part and divide that part. That would be a way to do it. It would work, but you'd have a fraction within a fraction, and then you'd have to fix that. There's an easier option to do here. And that is, when I brought the numbers inside, I could have brought slightly different numbers than I did. And that is, the 2's fine, but how about instead of bringing in 3, I brought in -3. And I made this a plus, so this becomes a -3. And the same thing here. I didn't bring really anything in for that one. What if I brought in a -1 from in front of that? Now, all of these are adding to each other. And so the property for adding is you merge them together and you multiply. So I put these first two together, and I get ln of x squared times y to the -3 plus ln z to the -1. Then I put those two together. And again, I'm still adding, so I'm going to multiply the things inside. Ln of x squared y to the -3 z to the -1. Okay? Now, I don't like leaving problems with negative exponents, so what I'm going to do is I'm going to say, well, wherever I have a negative exponent, that part is going to reciprocate. And my final answer is going to be ln of x squared over y to the third z. Y to the negative 3, that's going to reciprocate. Z to the negative 1, that's going to reciprocate. Those end up on the bottom, which is exactly what I would have gotten if I had done it the other way. If I had gone ln x squared minus ln y cubed minus ln z, I put the first two together, I would have got y squared over y cubed minus ln z. I would have divided there ln x squared y cubed over z, and the little trick to fix that is multiply top and bottom of your fraction by the little denominator, and you would have gotten x squared over y cubed z. Now, you get the same answer, it just seems a little bit more complicated. Now, if I only had two of these, I wouldn't have wasted my time bringing in the negative exponent. But since I had two minuses instead of just one minus in two terms, that's why I did it. It's a little trick you can use if you need to. All right. The last thing I want to talk about in this section, so you'll be expanding, you'll be condensing, putting them together, tearing them apart. Then you're going to be asked to do some calculating, evaluate some expressions, and round to so many decimal places. I think in our textbook at this time, it's talking about the nearest 10,000th, but different problems will ask you where to round based on that. And so they'll give you something like log 3 of 7. I want to round that. What is that approximately? Well, I know 3 to the first is 3. 3 to the second is 9. So if I want to get 7, it's somewhere between the first power and the second power. It's 1 point something. How do I figure that out? Well, there is what we call a change of base formula. So if you remember, I mentioned that most calculators in a previous video, they usually only have log, which is based on 10, or ln, natural log, which is based on e. Most calculators don't have base 3. Now, some more advanced calculators, they do allow you to check, to actually put different bases down there. But most standard calculators, most standard scientific calculators don't do that. So we need this change of base formula. This change of base formula looks like the following. Log b of a. So there's going to be two versions of it, depending on what you want to do. So if I want to write it in terms of the common log, just log base 10, what I can do is I can write this as log a over log b. So that's one way I can do that. So if I wanted to put in my calculator, what is this approximately? I could say it's log 7 divided by log 3 and round that off. All right, so I use my calculator for this. Log 7 over log 3. So this calculator, I hit 7, and then I hit log divided by 3, and then I hit log, and that equals that. Tenths, hundredths, thousandths, 10,000. So it looks like it's 1.7712. So 1.7712. All right. An alternative option is to use the natural log, and you do the natural log of a over the natural log of b. So same order. So I could have done the natural log of 7 over the natural log of 3. And so if I did that on my calculator, let me clear all this out. So again, 7 on this calculator, you do the number, then hit the ln, divided by 3 ln, and I got the exact same thing, 1.7712. So which one should I use? Well, it's up to you. I tend to use the second one just because it only has 2 letters for the log instead of 3 letters in the first one, but honestly, it doesn't matter. You'll get, what you can't do is mix and match. So if you accidentally did like log 7 on top, but the natural log of 3 on the bottom, and you put that in your calculator, So 7 log divided by 3 natural log equals, that's a totally different answer. So it has to be the same log both times. You can't mix and match there. That's the big thing. And kind of an easy way to keep track of this is just notice this value spot that's going on top, the base that's going on the bottom. Value spot goes on top, base goes on the bottom. You kind of keep that in mind, just kind of just follows along, you know, it'll help you remember that formula. Okay, so there's some more simplifying logs, log properties. Hopefully that'll get you through those next set of problems.